Now.
The class is officially started.
I wrapped one of these gifts. I wrapped it very well. Like a medical seal. So very
Good marker. I'm going to use it because I forgot my own. Haha. Take that. So, we shall continue our discussion of database security today. We now are to the point with things where we are beginning to integrate databases to external web interfaces. This leads us to a discussion of the worst and most commonly damaging, well, perhaps not the most common, but certainly if you're a hacker, the SQL injection attack is one of the best bangs for your buck in terms of the amount of effort you need versus the amount of data you can breach. So we're going to discuss the SQL injection attack. I'm going to sort of demonstrate for you live how you might go about producing an SQL injection attack. And further, I'm going to show you how many layers of security you have to disable for an SQL injection attack to be a thing that can happen. So, before we get into our practical demonstration, let's have a discussion of what the jolly heck an SQL injection attack even is. So, does anybody have any idea what a SQL injection attack is? Yes?
you insert a line of code for the SQL to perform, usually destructive or information gathering.
Yes. So the SQL injection attack, even looking no further than the name, is a code injection attack, right? So the idea is that you insert malicious code into a query or some HTTP packet in the hopes that the server that processes that packet is stupid enough to interpret what you send in such a way that any code you write is executed, right? So when you are performing an SQL injection attack, you are attempting to run your code on someone else's machine without them realizing it. As you note, SQL injection attacks are normally performed for malicious purposes. The idea generally is to breach data security policies to get at data that don't belong to you. As I noted previously, SQL injection attacks are generally when a hack or a hacker makes the news, it's because they managed to pull off an SQL injection attack against a reasonably large target. The example I always like to come back to is the PlayStation Network a number of years ago lost something like 500,000 accounts to an SQL injection attack. So SQL injection attacks can easily be defeated, but you must enforce the same kind of sanitization procedures that we use to protect our protect against XSS attacks, right? Same principle applies. The way that an SQL injection attack works fundamentally is by inserting programming logic characters into regular text. So in the case of an XSS attack, we do that by introducing script tags, which are interpreted as script tags. In the case of the, I'm going to sneeze. You cursed it. The preemptive bless you, and now it's going away. There you go. All right.
Now you don't get the satisfaction of the sneeze.
If it was important, it'll come back. So injection attacks. Where was I? Something about. Oh yeah, how to protect. So basically, so long as you're filtering out nasty little characters that, you know, constitute SQL query characters, your vulnerability to an SQL injection attack is quite low. In this case, as we're going to see, the important characters are things like quotation marks and semicolons and hyphens. Those are the important ones in an SQL injection attack. So, let us consider the SQL query which we were using to query our password, our credentials table in our database, in our database example that we've been working through the last couple of classes. We have select star from credentials where username is equal to, and then we have some form of injected text, right? This is the username as received from the client. So, you know, Mr. Krabs. This, formulated as a string, normally these are single quotes, gets sent off to the database to be executed, right? Now, remember, the method that we prefer you use is to go through the PDO object. The string itself has a question mark here, and we use the prepare statement and the execute statement to put the strings in there rather than splicing them into the string ourselves. The reason that we use the PDO object to do that is one layer that's looking for SQL injection attacks. So the purpose of the question mark, rather than just splicing the variable directly into the string, which is what we've been doing so far in PHP, is that PDO object has protections built in to prevent SQL injection attacks. In order to successfully pull off an SQL injection attack, we will have to bypass it. So, all well and good. So, the question is, what do we put here? Right? Normally this is just the username, but if we start including some special characters, we can go quite a bit further. Let's call this X. So, if X, alright, so SQL injection attack number 1. Do you remember our previous version of the database where we were looking up username and password, right? It was username and password equals Y, right? Something like that. Then, in order to validate login, all we're doing is checking to see that at least one at least one entry back, right? If this query returned at least one database row, then one database row had this username and password, meaning that those two credentials match and are in the database, right? That's how we did things before. We counted the number of rows that we got as a result. If that was 1 or greater, that's a successful login, right? There's a reason that we use password hash, right? Consider this little piece of nastiness. Let's make that y. Let's make x equal to dummy as well. It works even better if you do like that. Because it's expecting to put another single quote at the end, right? So if you take this string, splice it in, right? What you end up with is where username equals dummy, and password is equal to dummy, or x is equal to x, right? Now we start wondering about associativity, right? So we've got two Boolean operations, an AND and an OR. Which one will be performed first? Yeah, it comes first. So implicitly, here, right? So we calculate the results of does username. So we get all of the rows. So its username must be, something that it's a throwaway value. Password must be some throwaway value. What's the value of x is equal to x? True. Is it ever false? No. What is anything or true?
True.
Right? So this whole thing always equates to true. Always. Right? So, this tricks your login check. This will return every row from your credentials database. If your login check is as simple as, did I get at least one row back from my credentials database, this will check your login check without having to know any valid username or password credentials. Right? Does this make sense? Things can get nastier yet. An even nastier thing you can do. Let's say our y is equal to dummy and single colon. I insert the semicolon, terminating the statement, right? I then say something particularly nasty, like insert into credentials values sneaky man, comma, top that all off, another semicolon, and then, does anybody know what the comment character in SQL is?
Dash dash?
Yeah, dash dash. Putting the comment character at the end of your SQL injection attack ignores the rest of the query. Quite nasty. So what will this attack do? That's correct. It will add an unauthorized username and password into your credentials database. It will also bypass hashing, right? And you know that's now in the credentials database. Depending on how complex the system that's all someone might need to be able to gain access. Yes?
Could they also make that an admin?
Well, here's a question. Do you have a column in the table indicating whether or not people are admin? Right? If there is a column in the table indicating that whether people are admins, you can do that. Yep. You can give yourself admin privileges, sure. Might be stored in a different table. The other thing to understand, well, there are two things to understand, right? Number one, they have to know what the tables have been named to be able to pull this off, right? But a lot of the time, you don't name a table something creative. You know, in theory, you could like add some random characters to the table name to try to make it a bit more secure, but a lot of the time, people won't set their own databases up. They'll use a framework to set up things like login systems, right? Now, the framework should also include protections against this sort of thing, right? So, a little bit of knowledge of the database is required to pull something like this off, but if you have some knowledge of how these things are usually laid out, you're probably going to be able to make some educated guesses, and you might just hit upon the thing you need. Question?
I was going to say, I think in SQL there is a command that lists out how a database is structured. And if the website is set up in a way where, for some reason, prints the output of that SQL statement, just using that command to print out the layout of the database can give somebody way too much information that they should not have.
Oh, absolutely. The issue, though, is that it's very, it's very rare and not very good practice at all for you to directly output the results of an SQL query through a PHP script back to the client.
So they've never happened in that way?
Well, I'm not excluding the possibility.
Very unlikely.
Yeah, well, ordinarily, right, the PHP script will retrieve information from the server, but that information from the database server, is not necessarily kicked out to the client, especially if it's being used only for validating credentials and sent from the client, right? So, you know, if it's something else though, like, you know, view a post. If the post is in a database, then you are echoing the contents of that post in some manner to a client. So, you know, it depends. It's not like, we're gonna probably do an example where we're like just echoing JSON data from the database directly, but, you know. Unlike other forms of security breach, there's no real reason to do this, you know, so it's gonna be more rare than others. Whereas, setting yourself up in PHP for an SQL injection attack is something that it's easy, and a less aware programmer can easily get themselves into trouble by using PHP's basic constructs, right? And this is actually, among the developer communities of various sorts, the PHP language is credited with the existence of the SQL injection attack. The reason for this is that PHP makes it extremely easy to splice strings into other strings by just including the variable name inside of the string. This is like a design feature of PHP, right? So it was convenient, lots of people used it. Then the SQL injection attack comes along, taking advantage of it. Now everybody's like, oh no, plug the holes, plug the holes, plug the holes. But if PHP had drilled the holes in the ship to begin with, you wouldn't have all this water coming, right? So yeah. So would you guys like to see a practical demonstration of an SQL injection attack?
Sure.
All right, good. I'm going to do it whether you wanted me to or not. So it's good that you, at least a few of you want to see it. XAMPP. I'm doing this in XAMPP because I am absolutely not going to push this to a live server, especially considering, you may have noticed that like I'm just kind of not logging into CS Unix because I would, in order to do so, I would have to like put my my administrative level login credentials to CS Unix, my SQL server on the board, which I'm not going to do. Hi, Internet. Just not going to do it. So. We will require both Apache and MySQL. Let us set up the stuff we have to set up every time. Create database. It should be the same as your login credentials for CS Unix. Oh, yeah. There we go. There we go. Create table of credentials. Number of columns 3. First, we give an ID number. Auto incrementing. Go. Next, we have a username. We'll make that a varchar of size 64, and then we shall have a password. Field varchar 255. Bing bang boom. Save. There we go. We will be able to see our values as they get populated. Now, if we jump back to Canvas, I'm going to grab the login scripts that we've been working on over the last little bit. So I'm grabbing the loginsecurity.zip file published November 13th in the Avenue or the Canvas announcements feed. I accidentally published this to all sections, so you should be able to see it. Yes, I apologize. I do occasionally vandalize the course's announcements feed. So, I'm going to copy all of that into htdocs. There we go. Wow. I'm really surprised that the X folders have not been cleared on this Podium machine. That might mean that this computer has not been restarted all semester.
Maybe they just do it at like the start of every semester.
See, this is the problem with Windows. Windows sucks, its permission system sucks. There's no reason that I should be able to write to a root directory like this, but anywho. Attack! There we go. So if we go to localhost /attack, there we go. We have our friendly user login from previously. Let's open these up. Log in and register in VS Code. There we go. Let's just remind ourselves quickly what's going on here. So, in our register script, this is the version where we are hashing our password before writing it to the database. And this is the one where this is actually kind of not correct, actually. So, where is it? Let me just so this will do. Can you see that in the back?
Can you just make it bigger?
Can you zoom in just a little bit?
I can do that. Is that good?
Yeah.
Good. You had a question?
Oh no, I was gonna say.
So, I have reconstructed our unhashed password version. Note that I have included that if our fetch contains at least one row, that it considers the password validated. Now, I don't know if, I think I did this in the other class, but not this class. It's stupid, extremely stupid, I don't know why this is the case, but using the PDO object, fetch column, the function fetch column fetches the number of rows. I don't know why they chose to do that, but that's what it is, so that's my gift to you, is that knowledge that that particular screw up exists. I consider that a screw up. I don't know. Maybe some PHP experts is like, oh well, actually, if you consider like the rows as columns, and column is the correct word. It's like no. Shush. Rows are rows. Columns are columns. Math is math. All right. So let's just insert a few pieces of information into our database. So Mr. Krabs, 1, 2, 3. Password is money. There we go. Oh wait, I think I forgot to keep the, I think I kept the hash over here. So let me, yeah I did. Oops. Alright. No. No hashing. Disable all security. There we go. Stop. Let me just clear that entry. Delete. Oh hey, localhost seems to be working on Chrome for some reason. That's cool. So, register Mr. Krabs, password money. User successfully added. Taking a look. We have Mr. Krabs money. ID is 2. We add SpongeBob. Password is I am ready. User successfully added. Username Patrick. Password Patrick. Name is too short. Successfully added, and Squidward. Password is clarinet. There we go. So we now have some data. Now for the fun part. Let us formulate our SQL injection attack. So, let's see, first of all, if we can trick the login, right? I will show you, well, let's put a couple of echo statements in first, and I will show you, like, well, you know what? I'm going to disable a little bit of security first. So, the first thing that we have to do is we have to make this much less secure, right? We are using the parameters inserted into the query to add the username and password retrieved from the client into this query, right? So let's review this, right? This is our command, our SQL command that's being sent to the database. We save that to the command variable. In our database handler, which is the return result of creating our PDO object and logging into the database using the correct database name and the correct credentials, root and empty password are correct for XAMPP. If it's your SQL password on CS Unix, the username is your CS Unix username, and your password is stored in a file in your root directory. If you're having trouble finding your SQL password for CS Unix, let me know. I can help you out with it. But anyway, database handler object, we call the prepare method, passing our command. We then create a list of arguments, pass those arguments into the execute function, execute method, which substitutes these arguments for the appropriate places in the command while checking for SQL injection attacks. So we've got to disable all of these levels of security. We need to still prepare the command, but we are not going to pass arguments in the proper way. We are going to insert things directly. Oh no. Oh no, we've PHP'd. So, this is an unsafe practice. And while we're at it, just to hammer the point home, rather than using proper filtering to gather our inputs, let's just grab unfiltered data directly from, what is this? Post super global name. A shiver of horror should be traveling down your spines at this point. But sir, we have no protection left at all. It's like, yes, we are standing buck naked in the middle of the internet right now. The only thing saving us is the fact that this is not the internet, this is an XAMPP server.
Sir, quick, get Surfshark VPN.
Oh yeah, no, I am not. If they want me to plug VPN services, they can damn well pay me, just like everybody else. I am not sponsored by anyone. Silent here. So, there we go. Completely unsafe. Let's echo our command before we send it. And just for the sake of interest, once we execute this thing, let's also fetch all and echo that as a JSON. PDO, fetch, associative. This may interfere with fetch column, I'm not sure. We'll see. Basically, I just want to see what the result of the query is going to be. So that's why I'm doing this. Ordinarily, you wouldn't do this. Although it is useful for debugging. When you're working on assignment 4, this nice little line here actually shows you in direct HTML what your database access is actually producing from the database, which could be extremely useful when debugging your queries. So, good. So, let's just try a regular attempted login that should fail. Plankton, password is evil. There we go. Select from credentials where username is Plankton and password is evil, and we get blank. I should probably put in another break right in about here. There we go. There we go. Now, let's see if we can trick the login. Oh, you know what? I think I did it in such a manner that won't work anyways. Let me try. Let me validate that this works with a regular login first. Yeah, no, I'm missing braces. I'm missing these guys. There we go. So
Single quotes around the variable names.
yeah, because the string itself is wrapped in double quotes. If you put the single quotes in there, you don't have to escape them.
Yeah.
Right? If you were to use double quotes, you'd have to escape the double quote character, but you know.
What if you put them inside the curly braces without it too?
No, because that character is expected by database, right? Yeah, in the absence of those quote marks, that's not a valid SQL query, so that's why the quote marks have to be in there. Okay, good. Now, so it is working.
That does work.
Dun, 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 dun. Boom! Successful a successful attack. And you see how this has been formulated? Where username equals Plankton and password equals evil or X. It's the exact one that we did on the board, right? You can see that the return result of that is the entire database. For some reason, it's still saying bad credentials, though. Let's see here. Did I not open that up sufficiently far? Oh, it probably is interfering with fetch column. So this is what we do, just to make it even worse. There we go. There we go. There we go. So basically, I'm just pulling the data out into its own variable, and rather than using fetch column, I am counting the data because I now just have an array of associative arrays as I regularly would in PHP. So, save. Try that again. Oh, undefined variable. Count as an undefined variable? Oh, yeah, because it's a function, not a variable. There we go. Credentials validated. Oops. Right? So let's play a little game of cat and mouse, shall we? So it's kind of silly to validate a login if multiple rows in your credentials database come back. That would normally indicate a problem with your query. So So it is reasonable to check to see if exactly one is returned from your database. So if this is what we do, trying the same attack, although we are acquiring the entire contents of the credentials table into our PHP script, that is not validating our credentials, which means that the hacker is not in. So the hacker has to be slightly more clever. It gets a little bit long to fit in the text box, but we can also insert data, malicious data, into our database using insert commands. Semicolon, put our comment character in, and we are insert into credentials, username, password, values, plankton, and evil. Log in. There we go. Now, let's take a look at our database. Uh-oh, SpaghettiOs. Dramatic gasp. Question.
Can you just show the insert line again?
Yeah, absolutely. I'll copy it to a notepad so you can take a good look at her. It's the same line that we use to insert new credentials into the database, except we've hard-coded evil credentials to be insert. Yay. So, using this sort of thing, one could even conceivably contaminate other tables with such things as stored XSS attacks, right? If you imagine the database, imagine something that will be output to the screen like a forum post. Imagine you have a database containing forum posts, right? Imagine somebody cracks that database and inserts into every single forum post a cross-site scripting attack that redirects to some other malicious JavaScript, right? That means that you have a stored attack in like every entry in your server, which is another reason not to trust anything that's not inside of your PHP script, right? It's not actually a problem if people have injected an XSS attack. If you catch it using proper filtering, if people start getting weird things appearing on their blog posts that have been properly sanitized, that gets raised, that problem gets raised pretty quickly with the site administrators. The problem with these sorts of attacks is that you don't know that they're happening, and that they can go on for a while without your knowledge, right? These hackers need to be sneaky. it doesn't often happen in movies. It doesn't often happen like it happens in movies, where you've got like a hacker on one computer typing, and then you've got like a sysadmin on another computer typing, and they're like having a fight with code. It doesn't often happen like that. They will be doing their thing at different times, right? So, yeah, any questions? Yo.
You said it doesn't often happen like that?
Well, see, I have a PhD, and as long as a possibility exists, I will not say that it never happens,
Fair.
because that's one of the things they pound out of you when you do a PhD, is making claims you can't support.
Has it ever happened?
I don't know.
Okay.
The possibility exists. The possibility probably existed a great deal more in like the 80s or 90s, when, you know, the amount of time that a computer would take to execute code was like understandable in human terms, you know? Like, and you could literally catch an attack in the middle of it while it was ongoing. Because like, I guarantee you that any hacker worth their salt is not, you know, producing these attacks by hand. They're writing scripts to do this, right? Any questions? Yes?
I was gonna ask, when you go on like a website and it says like this website's untrusted, like how does it recognize it's untrusted?
Oh, that's a different thing entirely. So you mean like your browser pulls up a big window that says this site can't be trusted, right?
Yeah. Like how does it recognize that some things are trusted and some things are untrusted?
Two ways. I can show you an example though. Just give me a moment, just so we know we're both talking about the same thing. Oh, it actually worked. Okay. Normally, when I visit this site, it gives me that type of an error.
Yeah. And then you could like click to proceed or whatever.
So, two things will cause this. In the first place, connection using HTTP and not HTTPS. So, you know, basically, if your packet payloads aren't being encrypted, the browser will say, hey, these packets aren't being encrypted, everything that you say is going to be out there, right? Do you wish to proceed? Probably not. You'll have to click through like at least one thing to be able to say, I accept the risk and keep going, right? The other thing that can cause this is a certificate being expired or out of date or out of misalignment, right? So the HTTPS system, and I'm not super clear on all of the details of this, but I can give you like a vague outline of it. The way that HTTPS encrypts things, well, in order to encrypt things and decrypt things, you need encryption keys, right? Both the client and the server must agree on an encryption key prior to the sending back and forth of any important data, right? Any sensitive data. So basically, there's a handshake operation that occurs before you even access the website that establishes the encryption key, one mutual encryption key between the client and the server, so that packets sent by the client can be sent to the server encrypted by the client, decrypted by the server, and everything works. Right? My understanding is that this is the purpose of the the certificate, the security certificate, the certificate is or contains that encryption key. So if the security certificate is out of date or not, if there's a problem with it, basically you're bumped back down to HTTP. You don't have access to the HTTPS enhanced security of the encrypted payload. And so that's why not having that certificate set up is basically the same as not having HTTPS. And that's what that error constitutes. If anybody has a better description of that, if anybody knows a little bit more about that, I'm happy to hear them. Yes?
Another thing that can cause it is you can create your own certificates, but then they're self-signed. You have to get a valid certificate from a certificate authority. Like DigiCert is a really big one. So if you create your own, it's self-signed and it doesn't have a valid chain of authority or whatever. So it'll give you an error saying, hey, we don't know that this is a valid SSL certificate or TLS certificate or whatever.
You would agree with my general description of the process then?
I think so.
Yeah. I always find these classes fun because there's always at least one person in the room who knows anything more about what I'm talking about than I do. But yeah, so does that answer your question?
Yeah.
Good. Are there any other questions? So that issue is not completely unrelated to the SQL injection attack. Yeah. Any other questions? Comments? Concerns? Okay. I think that's about as much as I have to say about the SQL injection attack. So, we shall move right along.
Or end class an hour early, sir?
Yeah.
Okay.
Nice try.
Did you at least bring the gavel today?
I thought I would remember it, but then I didn't remember it. It's because I had about 3 hours of sleep last night.
That's fair.
3, maybe 4 hours of sleep.
Children?
Yes. Yeah. The littlest one is teething. She was screaming her head off between the hours of 11:30 and 1:30 last night. Yep, I will be happy when she's got all her teeth. She currently has 6, and she has to get 20. And the molars are the worst. These aren't even the bad ones. The incisors cut through even more easily. It's the molars that really... It's in this database security issues thing that was never published.
So is it same with the hashing stuff?
I assume I covered this in material because I assumed that Steve had just not gotten to formatting the document nicely, so I covered it.
Could that just be published even though it's not formatted, just so we have access for reference?
I may have just vandalized this on your behalf. We'll see if I get in trouble for that. I might get in trouble.
Say we were vicious. Say we were vicious and terrified, on us.
Okay, yeah. They held me down, kept punching me in the face until, and no, it wasn't even me. You guys held me in a corner while somebody else logged in with my credentials. Yeah.
Right.
There was nothing I could do. Okay.
So then it is.
Except I now have a video recording of this entire conversation. And due to my policy of extreme laziness with respect to video editing, there's absolutely no way in hell that I'll edit that out. So. All right. I'm hoping everyone will have a restful weekend. So, the cloud then. Cloud computing. Does anybody have any idea what cloud computing is? Vague definitions are also acceptable. Yes?
Dealing with the large servers that
Yes.
are bunkers.
True? Yes? Server farms are involved? Yes?
Is things like Amazon AWS?
Amazon Web Services is a famous cloud provider. Yes, very true. Anybody else? So,
Twitter and Discord.
Twitter and Discord, yeah, did you just read this off? Yeah.
Yes.
So, the cloud, right? The cloud is marketed in many ways. The general principle behind the cloud is outsourcing both data storage and processing to remote servers. The cloud isn't really a thing that could have developed under dial-up internet, right? Basically, it required internet connection to become constant and ubiquitous and fast in order for cloud services to be practical. Basically, any device where things rely on cloud content, right, must always be connected to the internet, right? Take, for example, the iPhone iCloud for photo storage, right? You have a, X number of gigabytes of photo storage on the iCloud, right? The number of photos you have on your own local storage can be very small in comparison to the number that are stored on the cloud. And when you are browsing your photos, you are downloading thumbnails of your photos from the internet in the same way that you would be if you were scrolling Instagram, right? And if you want a blown up version of your picture, it must be downloaded in full version from the server, right? So, that's one example of cloud. Cloud for storage. An example of cloud for processing. Does anybody remember Google Stadia? Yeah.
Never not lasting.
It did not last very long, no. So the idea behind Google Stadia was that you would take games, possibly video games that were, of elevated system requirements, shall we say. The idea was the game is actually running on Google servers, and you can interact with that game through anything that had a web client, basically. And this meant you could run like Crysis 2 on your tablet. Incidentally, all you gamers out there, is Crysis 2 still like the benchmark for like game that will melt your computer?
It's more of a meme.
I know it's a meme, but like, is there like a new, better, even worse?
The newest Call of Duty,
The newest Call of Duty? Okay.
all the time. It's always the newest Call of
It's
Duty.
usually like Cyberpunk or something.
Yeah, whatever the.
Yeah.
Cyberpunk, yeah.
Oh yeah, Cyberpunk, yeah.
Wait, wasn't it Starfield recently?
I see
Starfield?
Starfield as well, yeah.
Because-
Those two. Starfield and
Well,
Cyberpunk.
it's newest, but that's.
Okay. If I say Crysis 2 though, everybody will get me because it's a meme, right?
Yeah.
Anyway, so the idea is Google is running Crysis 2 and melting their servers, and and you get to run Crysis 2 on a tablet or something, right? But it's not running on your tablet, you're just getting the display, right? The problem with Google Stadia is that that's a lot of data. Like, you're talking about like full definition video running at 60 frames per second, which is better than YouTube can manage, right? Plus, somehow, you have to send controller inputs through HTTP packets, have them arrive at the Stadia server, get served, and then affect the game, send the game state back to your tablet. And this is supposed to be responsive enough that you can play a video game. This, for people whose the target market for this product will use wired controllers over wireless controllers because they don't like the local wireless lag, right? Google Stadia didn't work out. Bit of a technical problem. They were biting off a bit more than they could chew, I'd say. The other problem is, like, maybe you could manage that for like older games with less advanced system requirements, but in order to make a service like that work, you would need the new games with the highest system requirements, right? So that's another reason that just kind of flopped. But anyway, that's an example of them outsourcing the processing to the cloud. Does that make sense? So, over the course of this discussion, we are going to talk about how you set up a web API, and because when it comes to cloud services, a large part of how they operate is through web APIs. Over the course of this, we are going to see that there are more types of request packets than just GET and POST. A lot of web API revolves around the proper use of packet types. Like, going into this topic, we know GET, we know POST, we know POST encodes in the payload, GET encodes in the URL. We know that POST can send images, GET can't, or shouldn't at any rate. But, aside from that, we're not really, that's all we know, right? That's all we really know so far about the differences between these different types. So, there are a few different competing sort of ways of approaching this problem, but one of the biggest and most popular is representational state transfer, or the REST API. Now, when somebody says REST API, they are not saying, it includes this function, this function, this function, and this function. What they are saying is, we are using packets according to this this standard. You are still going to have to read the documentation, right? So, examples of services which provide exposed web APIs include Twitter, or X, FKA Twitter, Discord, OpenAI has an API, Amazon Web Services has an API. If you go to the networking side in the department here, there's a fair amount of affection for Microsoft Azure, which is Microsoft's cloud thingy. the guy that has a Tux the Penguin sticker on his laptop, so you can probably, and who's like, you know, if there was a Windows icon in the middle of my laptop, I wouldn't have bought it. Yeah, no, it's okay. It's all good. Windows is,
Better than Mac.
see, I was about to say necessary evil, but I don't even believe that. Yes?
Do you still have the Windows key on your laptop?
I know. I hate it. Yeah. I should put a little Tux icon on
That would be so cute.
it. Yeah. Ooh, I bet you could get one of those. I bet you could like custom 3D print a Tux cap for a key. Anyway, not important. I knew a guy in my grad lab at university who made like a sudden board with that was like a mini keyboard that with buttons that he 3D printed. It was kind of cool. But then it was like filled with memes that were out of date in 6 months. So
Should a little mini sticker.
hmm?
Should a little mini sticker.
Yeah, I agree. Yep, this is gonna happen. We refer to the Windows key as the super key, by the way. So, just to give you a flavor for what these web APIs do and what you can do with them, let us consider for a moment the XFKA Twitter API. Apparently they're coming out with version 2. I don't care. I'm probably never going to. So part of the point of an API is to sell you a product. The API is often a product that you are being sold. Access to the API is a marketable thing. With Twitter, you've got various access levels. If you start off at the free tier, you get 1,500 tweets per month posting limit at the app level, so you can tweet 1,500 tweets per month from a bot. These are bots. When Musk is complaining about the bots, you know, he gave them the API. Various other restrictions, access to the ads API. If you find that there's a business case and that you can make money off of this, you can then move to the basic level of access to the Twitter API, which includes a posting limit of 50,000 tweets per month that you can make at the app level. I'm not sure what the different distinction is between user and app level, but 50,000 tweets per month is we calculated this in the other class, and it comes down to a tweet every 3 seconds. I think we can redo the math though. Pretty sure I'm correct about that. No, maybe that's the next one. Let me see here. Calculator. I might be wrong. I'm often wrong. Let's see. 50,000 divided by 30 days in a month, divided by 24 hours in a day, divided by 60 minutes in the hour. Okay, so it's 1 tweet per hour, a little more than 1 tweet per hour. Okay, good. The pro tier, you get 300,000 tweets per month. That's the one that's like a tweet every 3 seconds. 30,000 divided by 30 days in a month, divided by 24 hours in a day, divided by 60 minutes, divided by 60 seconds. So it's like 7 tweets a minute. Okay. Anyway, I know I would unsubscribe. So there you go. And if you have higher requirements than that, then they have individual pricing. Notice the jump though from like hobbyist to professional. $5,000 a month to be able to tweet 7 tweets a minute, or 7 tweets a minute. The basic tier is $100 a month, and holy crap, that's still a lot of money. You know, at least for me, that's a lot of money. I don't know about you. So anyway, that's what an API looks like. It's a product they are trying to sell you, right? But on the flip side of that, if you write an API, that is a product that you can sell to other people. So, welcome to the new age of the internet. Is it just me, or are they like pumping pure oxygen into this room or something? Like, the air feels weird. Like it's cold, but like,
It does feel kind of cold here.
yeah, but like,
Maybe it's just because it's so cold outside today.
It always feels cool.
but like, I don't know, I like, my nostrils are cold, but that's the only part of my nose that's
It's like
cold.
you're in a casino.
It's like I have like an oxygen tube on. It's weird. The air here is weird. I don't like it.
Sir,
I think they should take it back. Yes.
Sure.
What?
one fact about the human body.
Yes?
We cannot detect oxygen going in. We
Okay.
can only detect carbon dioxide going out. So if we breathed in pure nitrogen, we would never know we would die.
I think I'll stick to planet Earth then.
Yeah.
Yeah. Or if I'm on a spaceship, I'm going to make sure that spaceship has instrumentation for that. Where was this? I had the. Oh, did I back out of it? Yeah, I did. So. A lot of these API accesses come down to interfaces which expose database operations, right? Now, as it turns out, there is a mapping between HTTP packet types and database operations, which I'm going to flip through this document a little bit to find the things I want to look for, which basically means I disagree with the organization of this document, but that's okay. Consider the following table. In addition to get and post, we now concern ourselves with put and delete, which are both HTTP packet method types that we can use. Literally, you know, when you've made your web form and you say method post, you can use method put, you can use method delete. There are other ones as well, but let's just concern ourselves with these ones for the time being. Get requests are meant to retrieve information. I want to get that, right? Post is meant to add new information. This is probably where the term post comes from. A Twitter post. It's been sent via post, right? Put. Put updates existing information, and delete is self-explanatory. These correspond to SQL operations in select, insert, update, and delete, respectively. So, when your PHP script receives a packet, it may receive a packet using any one of those methods. So we now need to be able to distinguish between these different methods in our PHP script. Things are beginning to become a little bit more complicated. yet, we are able to send parameters via, we are able to send query parameters, right, in the URL. Question mark, dot, dot, you know, parameter and parameter and parameter, right? Not all of these method types support query parameters in that way. We are going to learn of a new way that we can encode parameters in URL addresses without using queries, without using query parameters. I would like to draw your attention to Canvas itself. I know this is a little bit small and hard to read, but I would like, you know what, I'm going to copy it to Notepad in that case. Let's copy. There we go. You can see this at the back?
Yep.
So we have a query parameter here, right? But I would like you to consider the directory structure that is represented by this URL, if it is a directory structure. Courses. We have a folder for courses. Okay, fine. Then we've got a number,
It's probably like the course ID or something.
a course ID
Like
number.
the primary key associated with that course.
Something like this, yes. Rather like files and then another folder. Do we think that every file has a folder? Do we think that all of the files, do we think that we have like 17 million files in Mohawk's MyCanvas? Probably not, right? 17 million of something is a lot of something.
Maybe it depends on how often it gets, like old courses get cycled out.
Well,
The shells
yeah.
might still be there.
I think we've only had Canvas at this institution for like 4 or 5 years.
Oh.
So, it's not inconceivable that there could be, 14 million documents. Well, here's a question. How many courses run at this institution?
Beats me, sir.
Probably more than 100.
Hmm?
Probably at least more than 100.
Yeah, this department, the CSAID department, I think runs about 200 courses, individual course codes, right? Although that might, somewhere between 100 and 200 individual course codes, right? If you're generously assuming 1,000 documents for each of those courses, right? You're still nowhere near that number. You're still 2 orders of magnitude off. And the CSAID faculty is the largest faculty that offers the most courses at this institution. Everything else is smaller. We are larger than several other programs put together. Yes?
Is that number out of all the files on MyCanvas as a whole?
Well, see, the point I'm trying to make is that I do not think that that's the number of files on Canvas. I think that that is a serial number, right? This is the whole point I'm trying to make. Those look like parameters to me, not directories. So, the question though, right? The question comes to an even finer point if we consider this. Shouldn't that be a PHP script? Or some kind of file that we're fetching? We are instead presented with a serial number or some kind of number, right? Is that a thing that looks like you could execute it? Absolutely not. It's not. So this is how it works, all right? On an Apache server, if you create a file called .htaccess, you can write redirection rules which send packets to other PHP scripts. In fact, a PHP script or file does not even necessarily need to be targeted. Any request which is directed to a folder in which htaccess exists can be rerouted by htaccess to some particular PHP script. Does that make sense? So it's not that this packet has gone into the courses folder, into folder 92,989, then into folder files, then into folder with that even longer number. These folders do not even exist at the top level. Probably at the level of the courses folder, this request is hitting htaccess and getting redirected to a dispatching script. Does that make sense? Why do I call it a dispatching script? We're starting to get into, we're starting to hit upon this kind of idea of model view controller, MVC architecture. We're starting to really actually rub against that in a meaningful way, right? With htaccess, you are redirecting all or most incoming packets of possibly many different types to one PHP script. The purpose of that one PHP script then becomes invoking other PHP scripts rather than handling all of those packets itself, right? Up to now, we have not, when we did our login and register PHP scripts, two different PHP scripts, two different functions, right? We add a layer on top which calls the correct PHP script given the correct incoming packet type and incoming packet parameters. Does this make sense? Am I making some degree of sense? Am I not confusing you completely? Shall we see an example? Examples are always helpful. I should note that a little birdie told me that for this topic, it will be on the exam conceptually in terms of theory. Practical demonstrations will not be required of you on the exam, nor are they required of you in assignment 4. However, it is my position that you understand what's going on with these things best if you see a working example. So I will not only talk about the theory because this is a damn college. And you should see something working. Yeah. So, questions?
Having the model control and view kind of idea, that adds layers of security, right?
Well, not inherently. I mean, it makes it easier to tell where you would do certain types of security. By the way, using htaccess and making a dispatch PHP script, we are making a C. We are making the controller in model view controller. Does that make sense? It makes it like, if you have one point of entry for packets, then it's like the code duplication problem, If you've got 12 different PHP scripts which are all handling packet inputs themselves, then you must duplicate all of your security checks in each one of them individually, and any changes or updates that need to happen have to happen in all of them, right? So it's not flexible, it's not extensible, it's not modular. Contrast MVC architecture, if you have a centralized controller where all the packets are flowing into, that centralized controller can perform all of the necessary checks in one place as opposed to in 12 places. So it makes your security checking, modularized and better in that sense. So I guess yes, in that sense it would enhance security to use MVC architecture, but not in the sense that you get better checks. It's in the sense that you get a more modular architecture and software development as a whole is easier. Does that make sense?
Yes.
Perfect. So, if you'd like to follow along with this example, please create a new folder in your htdocs folder. Call it REST. Right? Now, do we have any Linux people in the crowd, aside from myself? What does it mean when you put a period in front of a file name?
It's a hidden file or folder.
It's a hidden file or folder, that's right. So, Windows does not respect that. Basically, if you're looking through a live actual Linux environment like the CS Unix folder, right? Or folder, the CS Unix machine, or any real actual Apache server that you will work on, like for a job or something, right? If you're wondering why things are redirected but you can't see an htaccess file, it's because it hides it by default because it's got a period in front of it. So in order to see hidden files and folders in Linux, ls-l lists all the hidden files. Or is it A?
It's a,
It's A, yeah. I usually do both.
yeah.
I usually do LA. L is like view permissions and like extended details. A is view all. So, yeah, pardon me, thank you. So, ls-a or -la inside of the directory will show you that file, which you may not see but still exists. Sound good? Anybody use Git? Anybody use git ignore? Anybody know what that means? Yes?
Isn't it when you wanted to, if you wanted to ignore a certain thing in your folder or whatever? Or
Yeah.
and it's usually what you just said, it's usually not there, you actually have to go to the view, view hidden folders.
Mm-hmm.
Or have an environmental folder, and if you have stuff that's you don't want the people to view, you kind of ignore it so no one else can view it.
Yes. It purposefully excludes files matching a pattern from inclusion in the Git repository. The rules for htaccess are the same for, the rules of where that file applies is the same for both htaccess and git ignore. It's this directory and all subdirectories all the way to the bottom. So, yes, good. Git ignore is also starts with a period. So, let's make another folder in here, call it API. And into this, we create this is a little bit tricky in Windows because Windows likes to hide your file extensions from you. So you must view file name extensions first to be able to properly rename the file. .htaccess. access, yes, Windows will complain about an unknown file type. Just open it in Notepad, plain text editor, it'll be fine. I know it doesn't have a file extension. I know it looks like it is a file extension. It's not a file extension. It's just a file, no file extension. It's a hidden file, no file extension. I know this is like a very Linux concept, but there you have it.
So htaccess is the name of the file?
htaccess is the name of the file. Technically, the file extension is also part of the name of the file, but yeah. Like if you call base name, you get the name, you get the file name and the extension in PHP. So, anyway, open it with Notepad. Look for an app in the Microsoft Store. Yes, that definitely was worth me having to click through it. Good Lord, how I hate Microsoft. All right, so now we come to the actual contents of htaccess. It requires basically a copy and a paste from, from in here. These two lines, this is all of the contents of htaccess that you require. Number one, rewrite engine on. This enables the path rewrite engine to make modifications. Second, we have rewrite rule.index.php. Now, the dot here is a wild card. In theory, you could write patterns to have different patterned URLs direct to different PHP scripts, but we're not going to worry about that. We're just going to redirect everything to one PHP script. Okay? Good. So, rewrite engine on. Rewrite rule dot index dot php, or I'm going to call it, yeah, index is fine. There we go. Save, 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 save. Now, we just need to make an index.php. So let's go in xampp, htdocs, REST, API, select folder. I trust myself, yes, thank you. You see htaccess is in there, that's nice. New file, index.php. There we go. Now, our URL/URI is now going to be encoding data in addition to files and folders. So what we need to do is we need to be able to pull the URL out so that we can work with it as a string. For the time, we're starting to run a little bit short of time, but we now make use of the server superglobal. And I forget what the, request URI. So, let's take a look at localhost. In the API folder, you can see that when we access when we access this folder, we are being redirected to the PHP script. Now, this is not in and of itself very impressive, as we would have auto-redirected to index.php in any event anyways. What is impressive, I can now add as many parameters as I want. It's executing the exact same script. I do not have all of these folders, and yet everything is being directed to my index page. Yes?
So like, when you do like the URI part, that part is like the blue part, right?
Could you speak up a little bit?
Like when you're using the URI part, like you know how you just input it, like you know in the code, this is a URI, that part is like the blue part, right? And like a link, or
Sorry, the blue part?
and like a link, you know when like you paste it, or no? I don't know how to explain it.
I'm sorry, can you speak up a little bit? The fan is interfering.
Do you know like the like when you like copy and paste a link, it's like blue?
Oh, yeah.
That is like, is it to ensure that it is like encoded in that way too, or?
No, I think that's just,
Because you know how you were talking about the CS Unix link?
yeah.
I'm wondering like how would you, never mind, like I'm wondering how would you input the parameters in that link that
Oh.
same way?
Oh, you just embed that in the URL, yeah.
Okay.
Yeah, yeah, absolutely. You can create a link to like if your question is, can I add those parameters like using a regular like HTML tag, right? Yeah, you just write that in the URL, and if
Yeah.
htaccess is set up,
Okay.
this happens. Question?
In the URL, if you have your localhost and then you did REST API, when you typed it in the URL, did
Yes.
that for the first part?
Well, remember that my htaccess file is residing inside of my API folder, which is inside of my REST folder in htdocs. So, it's like htdocs, that's the root. If I access just localhost with nothing else, this is what I'm accessing, right? If I access REST with nothing else, all I've got is the API folder in there, right? If I access the API, now I'm being redirected to the PHP script. Everything past this point, redirection to the PHP script, specified in the htaccess file.
So that index.php is in the API folder.
Correct. Yeah.
That's
Although technically speaking, you wouldn't need to redirect it to something in the same folder. You could probably traverse the path a little bit and, you know, put it up or down directories if you really wanted to, but it's not really worth the effort. For this example anyway. Good. So, so the next thing we have to do, extract parameters. We have our URL encoded as a, it's a string with a bunch of slashes in it. How do we remove, how do we break this into, say, an array of strings? Correct, we explode it.
It's a little thing from PHP.
So, echo JSON encode. I promise this is the last thing today. URI explode. Separator is slash. Make sure it's the right slash. Second is the string, which is URI. There we go. Ta-da! Oh, do I now have a handy and convenient list of arguments?
Oh.
Yes.
Why is the first item empty?
Because there's nothing on that side of
Oh, because it sees the slash, but there is nothing on the other side of the slash.
precisely so.
Right.
See, we got a slash in front. So the question is, yes, question?
I was gonna ask, like, what are we doing in terms of just like, are we making what are we doing right now?
Why are we doing this?
Yeah, like, is this making API, like, I'm not,
So some of the request types that we are going to use to pass information to the server do not support get style query parameters.
yeah, like putting it in the link?
Yeah, the information needs to be passed somehow.
Okay,
This is the somehow.
okay, oh,
Yeah.
I see, okay.
Does that make sense?
Yeah.
Yeah. Like put, for example. This is how we're gonna use put.
Yeah,
But again, this only becomes useful when you're doing stuff other than get requests.
yeah, and like, most of the times when you access information, it's like given as an array. Like, when you get information from the server,
Yeah.
it's like given as an array usually, right?
Well, it's given into the get super global. Yeah. This is a way of passing information in without using the super globals.
Okay,
Yeah. Does that make sense?
yeah.
Any other questions? So, next time, I will show you how to write, well, you can probably do it from just my description of it, but I'll show it to you anyways. I'm going to show you how to write a switch statement that allows you to switch between different request types so that you can you can invoke different PHP scripts based on what the incoming packet type is, and pass the appropriate information in. This is how the web API starts to form. The dispatch script gives, it routes between the web API and the internal PHP function API that will actually run and execute the code. So we're working on like an interstitial layer here. Question?
If you have a space, if it puts in a %20, is that just like the, like in the URL, like when you type that in? Like if you do as many parameters as I want, it pops up, but without the slashes? You can just remove one of those?
I'll show you what happens. Yeah.
So is that just like that's just like a placeholder for the space, the white space?
Yeah, it's like sanitize a character the same way that when we sanitize the beginning and end angle braces for script, they turn into like % something else, right? Yeah, it's basically that same mechanism. Because spaces are kind of tricky. Like Apache's, like Linux hates spaces. Do not ever use spaces in file names in Linux, because in Linux, the space character is argument separation. So just don't do it. Don't do it Windows or Linux. Use underscore or use hyphen if you want space, not use the actual space character, please. You can tell if someone is actually a Linux user or how often someone has used Linux by seeing how they name their files and see if they avoid spaces or not. But anyway, oh, yeah, time to go. All right, take her easy, folks.